In this problem, we have a Beanie Baby on the blade of a fan. The fan is started up with angular acceleration alpha, 0.7 radians per second squared. And then we need to figure out how fast is the fan moving when the Beanie Baby starts to slide? What time does it slide at? And then finally, what is its kinetic energy right before sliding? So start with step one of the procedure is drawing the free body diagram. So we have the Beanie Baby here. We're going to have its weight coming down, mass times gravity. We'll have the normal force from the fan going up. We'll have the centripetal force of the Beanie Baby trying to fly off. And then we'll have the friction force trying to hold it in. So next we need a coordinate frame. We'll say that this is X direction. This is Y direction. And then we can go for the equations. So first, we need to do sum of the forces in the Y direction. We can get normal force, then friction. And then sum of the forces in X, we can get V. Then convert V to omega, omega to T, and then find the kinetic energy. So sum of the forces in the Y direction equals 0, equals N minus mg. So N equals mg equals 9.81 newtons. Then the friction force, and this is going to be static friction because we want it not to move, or we want to see like right before it moves. So static friction equals mu times m times g equals 0.4 times 9.81, which equals 3.9 newtons. So then in the X direction, sum of the forces in the X equals 0, because we want, again, right as it's going to start sliding. So that is going to be mv squared over r minus f mu. So then V equals mu s times g times r. V equals 1.4 meters per second. But what the question asks for is angular velocity. Well, we know V equals r omega, so V over r equals omega equals 1.4 over 0.5 equals 2.8 radians per second. So 2.8 radians per second equals omega. This is the answer. That's how we got 1. Now to get 2, the time for sliding. So time to slide, we know that alpha equals d omega dt, but since alpha is constant, then we know that omega equals alpha t. This is a constant angular acceleration. So t equals omega over alpha, which equals 2.8 over 0.7, which equals 4 seconds. And that seems pretty reasonable. Like, I don't know if you've ever put a Beanie Baby on a fan and turned on the fan, but 4 seconds is about decent before it starts sliding. Then finally, we need to find kinetic energy. So that is independent of the time, but it does depend on the angular velocity. So we know KE is going to be 1/2 I omega squared. And we treat the Beanie Baby as a point mass. That's at distance r away from the center of the fan. So that is going to be 1/2 times m r squared times omega squared, which equals 1/2 times 1 kilogram times 0.5 meters squared times 2.8 radians per second squared. That equals 0.98 joules for kinetic energy. So to recap for this problem, we drew the free body diagram, assigned a coordinate frame, wrote our equations of motion. So we had y equation to get normal force and then friction, x equation to get the speed, changed linear speed to angular speed, then solve for time, and plug the speed into the kinetic energy formula to solve for kinetic energy.